Okay, so in this video we're going to be doing some practice with the rule of 7 and naming acids and bases at the end of this video. So we're going to go and start off with the rule of 7, and I'll provide a certain time in the description where you can just skip all the way down to acids and bases. But if you don't already know the rule of 7, I recommend that you first watch the rule of 7 portion, because some of the acids require for you to know the rule of 7, or actually most of them. About 90% of them that I have in this video. But anyways, okay, so what is the rule of 7? So your professors, they're going to teach you what the actual rule of 7 is, but I'm not going to teach you what it is. I'm just going to show you how to do it. Okay, so the rule of 7, it's called the rule of 7 for two ways. I don't know if this is actually why it's called the rule of 7, but it's because to me it kind of looks like a 7, right? And with the exception of oxygen and fluorine, they're not in there. There's also 7 elements in here. So acetylene, iodine, bromine, chlorine, nitrogen, carbon, and boron, right? 7 elements inside the rule of 7, right? There's also a little box here, a little special box of a group of elements that are just too cool for the rest of them. They think they're all special just because they have an extra oxygen. They have their own little table to sit at. But anyways, let's go and get started by writing down a little bit of some examples here. Okay, so the rule of 7, let me go to write this down here. Let me zoom out a little bit. Okay, so boron's up here, right? Boron, carbon, nitrogen, right? You know where they are? Okay, now you're gonna grab boron, carbon, and nitrogen, and you're gonna scoot them over twice. Okay, so we kicked out oxygen, fluorine. In the rule of 7, they're not included in sort of these important elements. Oxygen is in here, but it's kind of like the main constituent of everything, right? It doesn't. We just don't consider oxygen and fluorine. All right. So go ahead and grab boron, carbon, and nitrogen and scoot them over twice, right? So that your new periodic table should look something like this. Remember, you're only going to use this for the rule of 7, so don't write this on the exam and tell your professor that, oh, I watched the video and he moved nitrogen over here. The charge of nitrogen should be whatever, right? So don't do that, okay? So boron, carbon, nitrogen, all right? And then below nitrogen, we see chlorine. We also see bromine, and we also see iodine and acetylene, all right? So what is so special about these 7 elements right here? Well, that's a good question. So when we're talking about these 7 elements, we're always going to refer to the 3 reference oxygens. And when you name these, 3 reference O, and when you name these, you're going to replace the suffix with 8. All right? So you might have heard in maybe some commercials where they say, oh, do you take nitrates for chest pain? And what they mean by nitrates for chest pain is nitrate as in NO3. All right? Maybe they mean a different nitrate or some other compound with nitrate in it, but that is nitrate, NO3, and that also has a charge. Okay? Now, you might have learned in the other video with that the charge of the group 17, so the halogens, is -1, because all the elements in this group want to gain 1 electron. All right. So now, this one over here is -2, and that's group 16. Right. Remember, we scooted over carbon. We scooted carbon over to where oxygen is supposed to be, so that's -2, and this group over here is -3. Now I'm going to add on to -2 and -3, so don't forget about those yet, just yet. All right. So let me go and erase this nitrate right here. So okay, so let's just act like we're doing nitrate. Okay. So nitrate has 3 oxygens right here, right? And this is called nitrate. Okay, nitrate. You don't write the hyphen on your exam, just write nitrate. All right. So now, what happens if we remove an oxygen? So -1 oxygen equals, and you're going to replace the suffix with ite. Okay, it's no longer going to be 8. It's no longer going to be nitrogen. It's going to be called nitrite. Okay, and that's after we've removed one oxygen. Okay, so right here we have NO2. Oh, one hugely important thing that I forgot to put in these two is the charge. Okay, you are expected to put the charge. Okay, so nitrate, the charge is -1. Now, what about nitrite? What's the charge on that? Okay. Well, the cool thing about the rule of 7 is that you do not have to worry about changing the charge. Just look at nitrogen. Okay, there's nitrogen. It's inside the -1 group. Therefore, it should have a -1 charge. All right. Never changes with the amount of oxygens. Okay. So that's a cool thing about this. I always thought when I took the class at night that chemistry was just trying to trick you, but not in this case. All right. Okay. So we're missing everything now. Okay, so NO2 minus is equal to nitrite. Okay. Now, what happens if you remove another oxygen? So -1 oxygen. So at this point, we've removed two total. All right. What happens now? Well, you replace the prefix with hypo, or you add the prefix hypo. You say whatever, and then you keep the suffix ite. Okay, so if we were to write NO minus, this is going to be written as hypo nitrite. Okay, and that's how you write hyponitrite. Okay, so now we just finished removing some oxygens. What happens if you add one? Right? Let's see what happens there. So +1 oxygen. Oxygen O. You add the suffix per. You say whatever, and then you keep. Sorry, not ite. You keep the suffix ate. Okay. So right here, if you had NO4 minus, you would have per nitrate. Per nitrate. Alright? And that's NO4 minus. Okay? And that's going to be exactly the same thing for chlorate. For example, if you wanted to write chlorate, you would write ClO3. Look at the charge, it's minus. Right? You wanted to write perborate, it would be BO4, right? These all follow the same general rule of 4 oxygens means per and an ate, suffix and prefix prefix and suffix respectively, right? Except the charge changes. So over here, borate is inside the -3 column. So borate is right here inside the -3 column. So you give it a -3 charge like that. Okay. What about percarbonate? So CO4 2 minus, right? Because carbon's in the 2 minus section or group, right? So all those follow the same general rule with oxygens. They're all going to have the same prefix and suffix. The only thing that changes is the charge, and that's of course according to the group that it's in. All right. So let's go and grab the red here, and let's draw the four the 4 elements that are just too cool to be with the other ones, right? Because they're slightly different. Okay. So you have a phosphorus, you have sulfur, you have arsenic, and you have selenium. Alright? So now, what's so different about these guys right here? What makes them want to have their own little group? Well, it's a very, very important difference. But the difference between phosphorus, sulfur, arsenic, and selenium from the rest of the rule of 7 is that they have it's 4 reference oxygens. Okay? These guys had 3 reference oxygens. The box has 4 reference oxygens. Okay? And when you see 4 reference oxygens, guess what you're going to have? Suffix ate. Alright? It stays the same. Okay? Now, let's say you wanted to add an oxygen to this. So, +1 oxygen. What does this mean? You add this prefix per, you say whatever, and then you add the suffix ate. You keep that suffix, okay? So let's go in and take sulfate as our little example that we're going to carry on here. So SO4, and what's the charge? Well, you see that sulfur's right here, right? It's inside the -2 column, right? -2 is right here. So you should have sulfate with a charge of 2 minus, right? And notice it has 4 oxygens. Right? Now we added an oxygen, so SO5 2 minus is equal to per, right? The prefix per, and then you say self, and then you keep the suffix ate, right? So that's per sulfate. Okay? So now let's see what happens if you remove an oxygen. And it follows the same general naming rule as the rest of the rule 7, except you're dealing with 3 oxygens when you remove one, right? So SO3 2 minus, right? Charge stays the same. So you're going to add the suffix ite. So SO3 2 minus is equal to sulfite, not sulfate or per sulfate, sulfite, all right? So now let's say you wanted to remove another oxygen, so -1 oxygen. And so far you removed 2 total, right, from this. So you add the prefix hypo, and you say whatever, and you add the suffix ite, okay? So SO2 2 minus is equal to hypo sulfite, okay? And this general naming applies to phosphate or arsenate or selenate. Okay, so if you saw in your exam, what is the formula of per phosphate? Well, you would look at where phosphate is. Okay, it's in the area with 4 reference oxygens, right? And if you say per phosphate, remember per means you added an electron. So if your exam said, okay, what's the formula for per phosphate, you would write PO5, because you know that phosphorus in the rule of 7 has 5 oxygens, right? Making it per phosphate. And you would look at what column it is. Okay, it's in the -3 column. So you would write -3, right? And if you saw like another tricky answer choice like that, the exact same thing with the 2 minus charge, you would know that this is incorrect because the charge, right? Phosphate's inside the -3 column, not the -2. Okay? Alright, so hopefully you guys got that. Let's go and move down to some examples. Okay? Now, let's see, how can I grab this? Hold on, I'm going to do a little bit of surgery here. I'm going to grab all of this stuff that we just did. Let's see if it lets me copy it. I would hate to lose it and have to draw it again. Okay, it's not going to let me. You know what, let me just drag it down there. Apologize for all this stalling. Feel free to fast forward a little bit. Wait for me to get this through. Okay. Alright. So, provide the chemical formula and ionic charge of each of the following polyatomic oxoanions. Alright. So right here, the name of this compound is called chlorate. Okay, so what is chlorate? Let me draw this in green because it's part of that one. Alright, so chlorate, okay, so first of all, identify the root of the name, so chlor, okay, so what sounds like chlor? Maybe chlorine, right? So look for chlorine, you see chlorine is right here, right? Well, it is inside the rule of 7. The 7 elements that are sticking together because they have 3 oxygens, right? So chlor, and then you identify the suffix, which is ate. Right, we don't have per, we don't have ite, we don't have hypo, so it's just 8. So when you see 8 with nothing else, you know it's a reference amount. Okay, so since chlorine is inside the reference amount of oxygens, right, you know that chlorate should have ClO 3 oxygens. Okay, now what column is it in? It's in the -1 column, right? So ClO 3 minus is going to be the charge of chlorate. And that's the correct formula, as well as ionic charge, right? Let's move on to the next one. Let's do blue. Okay, so carbonate. So identify the root of the name. So it's carbon, right? What sounds like carbon? Maybe carbon, right? So carbon's over here. It's inside the -2 column. Let me go to erase this. Right? So we know that carbonate, we identify the suffix as ate. There's no per, there's no hypo, right? So when we see just 8, we know it's a reference amount. So carbonate, because it's inside the 7 right here, is going to have 3 reference oxygens. Now what's the charge? We already said it's in the negative 2 column, right? Over here. So it's CO3 2 minus, right? Let's move on to the next one down here. So borate. Okay, what's borate? Well, let's look at the root of the name. It's bore. What sounds like bore? Boron, right? So borate is going to have the reference amount of oxygens as well because it's 8. That's the suffix, right? So reference amount of oxygens is 3, right? So we know it's BO3. Now, what's the charge? Well, it's inside the negative 3 column, right? So we're going to call this BO3 3 minus, right? Okay, so let's look at nitrite. Okay, what's nitrite? Okay, they're starting to get a little bit more tricky, right? Nitrite. Okay, so let's identify the root, which is nitr. Sounds like kind of like nitrogen, right? So this should be a derivative of nitrate, right? But look at the suffix. It's nitrite, right? We know that nitrite means that we've removed 1 oxygen because hypo is not there. If it was hyponitrite, we would know that we've removed 2 oxygens. But because it's just nitrite and not hyponitrite, we know that there is only 1 oxygen that has been removed, right? So this is NO, and the minus 1 oxygen is 2, right? We look at what charge it is in. Okay, it's in the negative 1 column. So we know that the charge of nitrite is negative 1. Alright? So now iodite. Okay, so where's iodine? Iodine is right down here, right? That's iodine. So iodite means that we've removed 1 oxygen, right? Because the suffix ite means that 1 oxygen is removed. Notice there's no hypo, there's no per, there's no 8, there's nothing like that, right? It's just ite. So ite means that we remove 1 oxygen from the reference amount. Reference amount of oxygens in iodate is 3, right? So iodite means we've removed 1. So iodite should be IO2 minus 1, right? So hyponitrite. Let's go and take blue. Hyponitrite. Okay, so identify the root, which is nitr, like nitrate, right? Except now we see 2. What do you call it? We see a prefix and a suffix, right? So the prefix hypo means that there's been 2 oxygens removed, and that suffix ite right here also agrees with that, right? So 2 oxygens have been removed from the reference amount of oxygens in nitrate, right? So nitrate normally has 3 oxygens. The prefix and suffix tells us that there are 2 oxygens that have been removed, right? So this should be NO, just NO, and then charge negative 1, right? Charge stays the same. Doesn't matter how many oxygens you remove or add, right? Okay, so let's move on to the next. Hypobromite. Okay, what is that? So let's identify the root, which is brome. Kind of sounds like bromine, right? Now the suffix and the prefix tells us that there have been 2 oxygens removed from the reference amount. Now what is the reference amount? Well, let's look at where it is. It's inside the 7, right? If it's inside the 7, it means it has 3 reference oxygens. So 3 minus 2 is equal to 1. Therefore, this should be BRO minus. And funny little joke. Notice that the charge is negative 1. Want to hear a joke? And you say sodium hypobromite, right? It looks like, nah, bro, I don't want to hear your joke. Anyways, so sodium hypobromite is BRO negative 1 because it's inside the negative 1 column, right? Now let's do percarbonate. Okay, so what does per mean, right? What does per mean? Per means that you've added an oxygen, right? And of course this 8 is consistent with that. So we know we've added an oxygen to the reference amount. So reference amount of oxygens in carbonate is 3, right? Because carbon carbonate is it located inside of the 7 right here, right? So we know that we've added 1 oxygen, so 3 plus 1 is 4, right? So CO4 charge right here is -2. CO4 2 minus, right? Let's move on to the next one. Perchlorate, okay? So where's chlorate? Well, chlorate right here is located in the rule of 7, right? So it should have a reference amount of 3 oxygens, right? So chlorate right here, this little segment right here, should have 3 oxygens. Per means you've added 1, right? So 1 plus 3 makes 4, right? So ClO 4 minus. Okay? I just noticed I like that strategy. Let me continue using it. Okay? So sulfate. Where's sulfate? Now we've gotten to the cool little box down here. So where's sulfate? Sulfate is located right there, right? That's sulfur. Makes sulfate once you make an oxoanion. So we know that we're going to have S for sure, right? Now sulfate. Just sulfate itself has 4 reference oxygens, right? We're not adding, we're not subtracting anything. So we know that we should have SO4. What charge is it? Well, we know it's inside the -2 column, right? So SO4, 2 minus. Okay? Now phosphate. Let's move on to phosphate. Where's phosphate? Right there, isn't it? That right there is phosphate. Let me go expose the charges. So we know that this still has the same reference amount. Remember, it's inside the box right here, right? It's inside the box, so it should have 4 reference oxygens, right? We're not adding or removing anything. Based on the suffix is 8 with no prefix or no with no "ite" either, right? So it should have 4 reference oxygens, and it's going to remain those 4 reference oxygens to make PO4. Now, what's the charge? We see that it's inside the -3 column, so it's going to be PO4 3 minus, right? Let's move on to the next. Okay, so selenite. Selenite, where's selenite? It's right here, right? It's inside the box. And remember, the box has 4 reference oxygens. So let's just label selen as having 4 reference oxygens. Now, what does this ite tell us? The ite tells us to remove 1, right? Okay, so this is going to mean that we have SeO3. Where's selenate? It's inside the -2 column, right? So SeO3, 2 minus, right? Now perarsenate. Okay, so where's arsenate? This is the root, right? Arsenate. So what does arsenate have? Well, you see it's right here. It's inside the box, so it should have 4 reference oxygens, right? So we have a 4 right here. And this per, let's identify what this per means. The per means to add an oxygen, right? So we should have AS, 4 plus 1 makes 5, so O5. What's the charge? Well, arsenic is located in the -3 column, right? So it should be ASO5 3 minus. Okay? Let's move on to the next. And the last one. I know these have taken a while. Hopefully you've already skimmed through the video, so you avoided having to listen to all these. But anyways, hypophosphite. Let's see. Okay, so what's the root? So we have phosp, right? We have phosp. So phosphate normally has how many oxygens? 4 reference oxygens, right? Because it's inside the box. So we know that 4 reference oxygens. So what does ite mean? Well, like always, ite means we remove 1 oxygen, right? But what about hypo? What does this hypo mean? Hypo means we remove yet another oxygen, right? So 4 minus 1 minus 1 makes 2, right? So we should have P, as in phosphorus, O2. What charge is it? Now phosphorus is located in the -3 column. So this is going to be 3 minus, right? PO2 3 minus. Okay? Now, let's go and move on to acids. Okay? Now, the mnemonic that you're going to be using for acids is the following: ic, I ate that horrendous bite. All right. If you had Dr. Beckfar, chances are you've heard him say this, because he likes to use his mnemonic. He used it when I took the class. But anyways, you're going to be using this. Okay, so let's see what we have here. We have phosphoric acid. Okay, so we have to give the name of this. All right. Oh, we have to give the formula of this. Actually, I don't think I included examples that can go with this, but don't worry, we can make some of our own. Let's go ahead and set that to the side. Right. So provide the chemical formula or the name of each of the following acids. Right. So phosphoric acid. Okay. Actually, no, we can apply this mnemonic. Okay. So phosphoric acid. Okay, so what does phosphoric acid even mean? Okay, so let's identify the roots. We've seen, not or, we've seen phos before, right? Now, phosphoric acid is a little bit weird because instead of saying phosphate or perphosphate and then just making phosphic, we add the or just to make it sound cooler, I guess. So phosphoric acid, okay? But the phosp is our root, okay? So now what does ic mean? Well, according to our mnemonic, ic becomes 8 when you're trying to convert back to the what do you call it? The polyatomic oxoanion. All right? So phosphate, and we remember from before that phosphate is inside the box, right? Let me go to draw that box down here again so I don't have to drag it down. Let's go and draw it in green again. So boron, carbon, nitrogen, chlorine, bromine, iodine, astatine, and let's go and draw this in red again. So phosphorus, sulfur, arsenic, and selenium. Okay, this is a cool little box. They sit by themselves. Okay, and let's go to label this again as -3, -2, -1. All right, and that's going to help us with how many hydrogens we should have. Right? So phosphoric, so ic becomes 8. We know that because phosphorus is located right here in the box, that phosphate should have 4 oxygens, right? So let's go and write down PO4. Now, remember that the charge is 3 minus. Well, what's the charge of a proton? Or, yeah, a proton. So we write protons as H plus, right? That's what an acid is. It has protons attached to it, right? So we're going to cross these charges. Hopefully you've seen my other video, but we're going to cross these charges in order to determine the chemical formula for that. All right. So the 3 goes over here to this spot. The 1 goes over here to this spot, and we're going to get from this H3PO4. Now, if you don't like doing that crossing thing, you can think of it as this way. Okay. So when we do acids, we're trying to get the overall charge to be 0, right? So right here, it takes 3 hydrogens, 3 protons, to cancel out the 3 minus from the phosphate. Okay? It takes 3 of them. So 3 plus minus 3 gives 0, right? So the overall charge of this acid is 0, right? It's a stable compound. Okay? Now let's move on to the next one right here. Okay, so HClO3. Okay, well, let's identify what polyatomic oxoanion is in there. Okay, so ClO3. We know that ClO3, so there's Cl right here, right? It's inside the rule of 7. We know that the rule of 7 has 3 reference oxygens, right? The elements in this rule of 7 has 3 reference. Let's go and establish that right here. And there's 4 reference. It's inside the box, right? So ClO3 has 3 reference oxygens, therefore ClO3 should become chlorate. However, remember that 8 becomes ic, so this time we're going this way. So 8 becomes ic, so this should be chloric acid, right? Now let's move on to the next one here. Whoop. Sorry about that. But anyways, perbromic acid. Here we have brom. Let's go and isolate brome. Okay, So brome, that's what we have right here, right? So we're doing something with bromine down here, okay? So what does ic mean? What does the suffix ic mean? Well, ic means 8, right? Let's go and do this. So ic goes to 8. So we know we're doing something with bromate, right? Well, now we also have this per. Okay, so per bromate. So this becomes per bromate, right? So per bromate, what does per bromate mean? Okay, so bromine down here is inside the rule of 7, right? It's inside the 7 elements right here, not the box. It's inside the 7, so it has 3 reference oxygens, right? Well, the per means we added an oxygen, right? So per bromate should have BrO4, right? So BrO4 has a charge in -1 because it's inside the -1 column. So, and a proton has a charge of +1. You cross those charges up, or you just say, okay, it takes 1 + 1 and 1 -1 to cancel each other out. So this becomes HBrO4, right? Let's move on to the next one here. Okay, so H2SO3. Okay, so what is H2SO3? So let's look at SO3, because that's the name, right? That's where the name comes from. So now, let's go look for sulfur here. Okay, so where's sulfur? Sulfur is located inside the box, right? We know that the box has 4 reference oxygens. So we removed an oxygen, right? So because right here we have H2SO3, not 4. So now, since we have SO3, we know that we removed an oxygen, right? So we should have not sulfate, but sulfite, right? Sulfite. So now, ite becomes us, right? Ite becomes us. So we know we have sulfurous acid. I think that's what it's called. Not sulfus. I think it's sulfurous acid. And phosphorus and phosphate and sulfate are the only two that add that little UR. I guess it sounds more natural. Maybe you can ask your professor about that. But anyways, let's see what color we're using. Red. Okay, so nitrous acid. So let's go ahead and identify nitre. Okay, so what does us mean? Us goes to ite, right? So we know we're working with nitrite. Okay, so ite means we removed. Okay, so we know that this is translating to nitrite, right? Well, the ite means we removed an oxygen from the reference amount. So right here we have nitrate is inside the 7 with 3 reference oxygens, right? So we removed 1, so therefore we know we should have a backbone of NO2 minus, right? Now the charge of a proton is +1, so it takes 1 + 1 to cancel out 1 -1, so this becomes HNO2. Let me go to box in the answer. Okay, so let's see, what color is next? Green. Alright, so let me go and erase all this. Okay, so hypochlorous acid. Okay, so what's the backbone? We know that we're working with chlor, right? So where's chlor? Chlorine or chlorate is located over here, right? It's inside the 7. So when we know it should have 3 reference oxygens. Okay, so what does hypo mean? Hypo means we removed 1 oxygen, right? And if by now, hopefully you can determine that us goes to ite. And ite also means we removed an oxygen. So far we've removed 2 oxygens from the 3 that are reference, right? So we know that we should be working with ClO minus with 1 oxygen, right? Charge of a proton +1. It takes 1 + 1 to cancel out 1 -1. So we know we should be working with HClO, right? HClO. That's a chemical formula of hypochlorous acid, right? Let's move on to the next one here. Getting mixed up with my colors. Okay, so blue. Hyposulfurous acid. Okay. So we know that sulfate is located inside the box, right? Hyposulfur. Let's go and isolate that. So hypo means we removed an oxygen. Us, just like before, means we have ite, which means we removed another oxygen. So sulfate, because it's inside the box right here, we know it should have 4 reference oxygens, right? So we should be working with SO2. What's the charge? It's into the -2 column, right? So SO2, 2 minus, charge over proton is +1. So it takes 2 plus 1s to cancel out 1 -2, right? Or you can just do it the easy way and cross them up. So you get H2SO4. No, not SO4, SO2. Sorry about that. And the 1 stays right here, right? There's an imaginary 1 outside of that polyatomic ion. But we don't write it because it's unnecessary, right? So H2SO2. That's our answer for that one. So H3PO2, let's see what's that. Okay. So H3PO2. So what is PO2 again? So PO2, so where's phosphate? Okay, so we know that phosphate's inside the rule of 7, right? Inside the box, I mean. So it has 4 reference oxygens. And right here we see a phosphate, a derivative of phosphate with only 2 oxygens, right? So we removed 2 oxygens. Well, what do you add when you remove 2 oxygens to the name? You have hypo, right? So right here we have hypophos 4, and then remember 2 means we also have the suffix ite, right? Hypophosphite. Let me go and just write that for now. Hypophosphite. Okay. So ite becomes us, right? So this should become hypophosphorus acid, right? That's the name of that acid. Okay. Let's go on to this next order here. So HNO3. Okay. So what is HNO3? Okay, so NO3 is located right here, right? That's where nitrate is located. Now, we don't add anything, right? Nitrate normally has 3 reference oxygens as depicted right here, right? So we're going to go ahead and keep that, we're going to keep the name as nitrate, right? We're not going to add anything. And if you look over here, 8 becomes ic. So now we know that right here we have nitric acid, right? Last one right here, H2SO5. Okay, so where's S? S is right here, right? Now, because it's inside the box, it has 4 reference oxygens. Right here, we see a derivative of sulfate with 5 oxygens. So we know we added 1, right? So when we add an oxygen, we know we add per. Let's just write per sulfate right here. So per sulfate becomes per sulfuric acid, right? So 8 becomes ic, so per sulfuric acid. Not pure sulfuric acid. Per sulfuric acid. Okay? So those are acids right there, right? Now, something that's extremely important that we need to cover right here. What is the difference between hydrochloric, which I'm sure many of you have heard of, hydrochloric and chloric acid, right? Now, throughout my experience of peer leading, many students think that hydrochloric and chloric acid are somehow synonymous, all right? They are not. Hydrochloric acid and chloric acid are completely different molecules with completely different constituents and also very different acids, all right? They're not even the same strength, okay? So when you see hydro, what I always like to think of is a 1-to-1 ratio, okay? So when you see hydro, you know you're going to have 1 proton with 1 halogen, okay? No oxygens involved, like how we just spent last half an hour doing over here. It's just 1 proton with 1 halogen, no oxygens, okay? No polyatomic ions. So when you see hydrochloric acid, maybe I shouldn't say erase that. I don't know how to redo on this thing. Oh, here we go. 1 proton with 1 halogen, right? No oxygens. Let's make that very clear. No oxygen, okay? So if you see oxygen, don't call it hydrochloric acid, okay? So hydro and chloric means that you have 1 proton with 1 halogen. Chloric corresponds to chlorine over here, right? So we know we should have HCl. That's hydrochloric acid. Now let's do it in red to get the big contrast to show you the difference. So chloric acid. Chloric acid pertains to everything we just finished doing over here, right? So chloric becomes a 0 here. Ic goes to 8. So we know that we're working with a derivative of chlorate, right? So what is chlorate? Chlorate right here. I'm sorry if you hear those fireworks. I think there's a game going on, football game. But anyways, ClO3, right? With a charge of -1 because it's inside the -1 column. So you should have one proton in there, right? So HClO3. Now ask yourself, you don't even need to be a chemist or any sort of, you don't even have to be taking the class to know that HCl is not the same thing as HClO3. Okay? So just get that through your mind, okay? So just think about it. And don't make that mistake on the exam, okay? Don't panic and say, okay, HClO3, oh, I see an H and a Cl. I'm gonna go ahead and call it hydrochloric acid, okay? It's completely not the same thing, okay? I'm trying to stress that very, very well, okay? Now, same thing over here. Just another example. Hydroiodic. Don't call it hydroiodic if you see iodic acid, okay? So hydroiodic, remember it's 1-to-1, one proton with one halogen, no oxygen, okay? So hydroiodic should just be H. That's charge of one proton. Iodine is negative, so Hi, so that becomes just Hi. That's hydroiodic acid. So iodic acid, we know that we're working with iodate. Iodate becomes iodic, right? Or actually, should have been the other way around. So we know what we're doing. IO3. Charge of IO3 is -1 because it's inside the -1 column over here, right? Trying to get your attention. Anyways, the charge of one proton is +1, right? It takes 1 + 1 to cancel out 1 -1 to give us HiO3, right? That's iodic acid. Hi is not the same thing as HiO3, okay? So if you see an exam and they ask you to name, let's just say they wrote down this, okay? We're gonna use hydrochloric, or no, chloric. I just made the mistake. I'm trying to stress you not to make, right? So if you see answer choice A, B, C, and D, let's say this is hydrochloric acid. This is chloric acid. This is chlorous acid. And then let's just say perchloric acid. And answer choice E, let's just call this none of the above. Okay? So we know that if you look at this, right? Look at what it has. Okay, it has oxygen in there. As soon as you see that there's oxygen in there, cross off hydrochloric acid. Okay, just cross it off. Don't even worry about it. Now you can give yourself 4 answer choices that may or may not be wrong. Okay, so hopefully by now you can ascertain that it's chloric acid, right? Okay, so hopefully I stressed that enough. Now the last of this video will just be over bases, because I thought might as well cover bases if I'm covering acids. So barium hydroxide. So let's go and locate barium. Okay, so barium is located over here in the second column of the periodic table, right? And this column of the periodic table has a +2 charge because it wants to give up 2 electrons, right? So barium is +2. Hydroxide. Okay, so what's hydroxide? So if you're taking organic chemistry, you're going to be seeing hydroxyl a lot. Hydroxyl is when hydroxide is covalently bonded. So, for example, acetic acid. I'm sure you guys have heard of acetic acid in your workshops. So this right here is a hydroxyl. Okay, you do not have to know this for your Gen Chem 1. Okay, so that's organic chemistry. But anyways, hydroxide is OH minus right here. That's hydroxide. Okay, so let me draw this over here. Hydroxide is equal to OH with a charge of -1. Okay? So we know hydroxide has a charge of -1. Okay, so let's write Ba2 plus and OH minus. Okay, so when you see this, okay, I always see students make the mistake of just putting the 2 with no parentheses. Okay? So when you see hydroxide, treat it as one good, big, happy best friend. Okay? So O and H are best friends. Okay? So if you're going to double hydrogen, you're going to have to double oxygen as well because they're both best friends, right? So when you cross the charges right here, you put parentheses around it if there's more than one, and you say Ba parentheses OH, and you're saying there's 2 OHs. Because you can't just say Ba. If you say BaOH2, then you're saying there's barium with some water, okay, which makes no sense as far as I'm concerned. BaOH2, that's a completely wrong way to write barium hydroxide, okay? You have to have the parentheses. Okay? If you notice over here, rubidium I kind of just gave away the name, but RbOH kind of just goes against what I said, but notice that there's only one. Writing parentheses around 1 is not necessary. Okay? If you see on the next one over here, MgOH2, there is a parenthesis around the 2, around the OH to separate it from the 2, right? So make sure you use those parentheses. Okay, so Rb. So what's Rb? Rb is located over here, right? Hopefully you know that Rb is rubidium. And then what's OH? Over here it says rubidium and OH is equal to hydroxide, so rubidium hydroxide, right? Okay, so let's go on to the next one. So Mg, what's Mg? So Mg is located on the second column, right? That's one of the common elements that you should know, that the name of by heart. So Mg is equal to magnesium. Please don't confuse that with manganese, which is located over here. Okay, magnesium is Mg, manganese is Mn. Okay, so magnesium, and what's the OH stand for? That's hydroxide, right? Magnesium hydroxide. And this is a this is an ionic bond, okay? So of course the OH, that's covalently bonded, right? But since the OH itself is bonding with magnesium, which happens to be a metal, this is an ionic bond, okay? So you don't put magnesium dihydroxide, you just put magnesium hydroxide, okay? Those di, tri, penta, hexa, whatever, those all correspond to covalent compounds. Magnesium hydroxide, the bond between magnesium and hydroxide is ionic, however. Well, I just erased like the whole name. However, the bond between H and O in hydroxide is covalent. Okay, so you don't have to worry about that for the sake of this video. But just know that it exists, okay? Just know that's the thing. Lithium hydroxide. Okay, so what's lithium? Again, lithium is one of the elements you should know the name of by heart, okay? Lithium is located over here, and the charge of this column of the periodic table is +1 because they want to gain 1 electron. No, they want to lose 1 electron. Sorry about that. They want to lose 1 electron, so lithium is +1. So let's write Li plus. We just finished drawing hydroxide, right? You know, hydroxide is -1. So let's go ahead and cross up the charges, so it just becomes LiOH. And again, it's not necessary to draw the parentheses around OH because there's only one, okay? Now the next one, strontium hydroxide. Now, where is strontium? Okay, we see that strontium right here. Maybe you don't know where it is exactly yet because you're new to chemistry, but strontium is Sr, and it's located right here in the second period or second group of the periodic table. Okay, so we know that the charge of strontium is +2, right? Because it's inside that column. So Sr 2 plus hydroxide. Okay, what's hydroxide? Over here we see that hydroxide is OH, right? OH minus, right? Cross up the charges. So we get Sr1, right? We don't have to write the 1 though. Parentheses OH2. And that's how you write strontium hydroxide. Remember, it's very, very important you write the parentheses, okay? You don't want to miss a question like that on the exam, should there be one. Alright, so what's K in the next one right here? So what's K right here? Well, K, hopefully another one that you should know by heart. is potassium. So potassium, and of course we know OH is hydroxide, right? Potassium hydroxide. So this last one here, it's been a long half an hour or 45 minutes, however long it's been so far. Calcium, Ca, another one you should know by heart. Calcium, and what's OH2? Or just OH? Calcium hydroxide, right? So, hopefully you guys found this video helpful. Thanks for watching.